Our last video was on factoring and simplifying, and we're going to do more of the same, factoring the greatest common factors today. So simplifying is when we, distribute and get rid of parentheses and combine like terms. This becomes 20x squared plus 12x plus 8. We're pretty familiar with that. Factoring is us undoing the simplifying in a lot of ways. Notice how this right here is matching this right here. If I look at each individual term inside this expression, I notice that all of them can be divided by 4. So what I'm going to do is factor out a 4, leaving me with a 5x squared plus a 3x plus 2. So this right now is in factored form, whereas this over here is in standard form. Both factored form and standard form have some very useful applications and their own sets of strengths and weaknesses, so we're going to be familiar with both. So let's just spend some time factoring out greatest common factors and getting a feel for that. Here, I look at every single term and I see that each term can be divided by 3. Since each term can divide by 3, I factor out a 3. So I am going to divide each term by 3, but I don't write it like I'm doing this, because the 3 still exists. The 3 is still a part of the expression. It's just now out in front, multiplying everything. So the greatest common factor of this expression was 3, and I pulled it out. So the greatest common factor of this expression was a 3. Take a second and see if you can find the greatest common factor of these 3 expressions, and then see if you can actually factor them. In the first one, our GCF is 4, leaving me with this. I divide each term by 4. In our second one, the GCF is 20, so I divide out a 20, I factor out the 20. In the third one, the GCF is 1. There is nothing these have in common, so I can't factor this any further. It's in its standard form and it can't factor beyond this. Okay, a couple things to hang on to now. If the leading coefficient is negative, and we talked about leading coefficient last time, the term on the biggest power, if the leading coefficient is negative, factor out a negative. So I'm going to factor a negative 5 out of all of this, which causes the signs of everything inside to switch. If your leading coefficient is negative, you factor out a negative. So here I'll plot a negative 2, leaving me with a to the third minus 3. And here I'll pull out a negative 4, leaving me with 2y to the fifth minus 3y squared plus 4. So when you factor out a negative, everything inside your parentheses is going to switch its sign. What was negative becomes positive. What was positive becomes negative. Here's another important trick. If every term has a variable, then you pull out the lowest power of that variable. So notice how here, every single term has at least one x in it. Well, the smallest power that I see is x squared. So I'm going to pull out an x squared. I can also pull out a 3. There's a GCF here of 3x squared. When I pull that out, I'm going to be left with x squared minus 2x plus 4. So if every term has a variable, you pull out the lowest power that you can see. Here, the GCF, there's no coefficient GCF, so 9, 8, and 7 are all, they have no common factor. But I can pull out an x cubed, so I get 9x squared plus 8x plus 7. Notice how each power just dropped by 3. 5, 4, 3 became 2, 1, and then no powers. Here I'm going to pull out a negative 2a. When I pull out a negative 2a, I'm left with a plus 6. And remember, the way you can check, so this is my factored form, but the way you can check is you can redo your distribution to see if you get what you started with. Okay, so you can always check your factoring by just redistributing and seeing if you get what you started with. So this is a pretty quick video. It just kind of has us running through greatest common factors one last time. There's one last case I want to point out. If your GCF, which in this case is a 3a, I'm going to pull out a 3a. If your greatest common factor matches your last term, when I pull out a 3a from this, I'm going to be left with a squared plus 4a minus 1. 3a divided by this 3a still leaves me with this minus 1. You have to have that minus 1 there The temptation is often for students to make it blank. But don't make it blank. Just leave that one there as a placeholder. Okay, we're done. Solid work.